Hello, grade 11s. Hopefully you are doing good. I want us to prepare for June paper 1, mathematics grade 11. I'm having different question paper that will be very useful to us. I have this question of Gauteng province grade 11, June 2024. I have KZN grade 11, June 2024. And I also have got LIMPOPO. Okay, so these are the questions that I want us to look for. It is a June exam paper, so we know what we are expecting for June. So let's start with this problem of Limpopo. I'm going to start with functions first. Why? Because functions carry a lot of marks. And if you master functions from grade 11, let me tell you, grade 12, paper 1, you have passed. Once you pass your grade 11 functions very well, you stand a good chance of passing grade 12. So let us look at question 3, which is a hyperbola function. So let's go with hyperbola function. How do we know that this function f of x is a hyperbola? X is the denominator. Whenever you have got a function whereby x is the denominator, something like, let me also say something like g of x equals to 2 over x. This is a hyperbola function. Why? My guy here, x, is the denominator. So remember this, whenever your variable x is the denominator, you know that you are dealing with a hyperbola function. So let us observe these questions. 3.1 say, write down the equation of the asymptotes of f. What is the examiner looking for? The equation of the asymptotes of f. So this hyperbola function has got two asymptotes, and this is what they are looking for, the equation of those asymptotes. Hyperbola function has got what we call the x asymptote. And this x asymptote, it is called a vertical asymptote. Know your language, or no, let me say, know the language of mathematics. We are dealing with maths. We must know the language of maths. So when we talk about the x asymptote, we are talking about the vertical asymptote. Another asymptote is the y asymptote. The y asymptote, which is a horizontal asymptote. A horizontal asymptote. So we have to find the equation of these two asymptotes, the x asymptote and the y asymptote. So how do we find the equation of the asymptotes? To find the x asymptote, you are going to equate the denominator to 0. Look at the function f of x. What is my function f of x? F of x is equals to 1 over x minus 3 minus 2. So what is the denominator? When you look at this f of x, the guy underneath, it's x minus 3. X minus 3 is your denominator. So you take x minus 3, you equate it to 0, therefore x equals to 3. So this is the x asymptote. And what is the y asymptote? Go back to the function. Go back to the function f of x. The number standing alone, -2. This number here, -2, if you come back to f of x, the number at the end, it's our y asymptote. What is the equation of the y asymptote? Y is -2. So 3.1, they say write down the equation of the asymptote. So what is your solution? X equals to 3 is the x asymptote. Y equals to -2 is the y asymptote. So you found the equation of the asymptotes of f. Don't forget this. Hyperbola function has got two asymptotes, the x asymptote and the y asymptote. Now, okay, let me not rush into finishing. Let me go deeper here. Let me go deeper. This x asymptote and the y asymptote can be presented on a Cartesian plane. So you can think about, this is my y-axis. Let me use the red color. I think the red color is more visible. This is my y-axis. This is my x-axis. Now I want to show the asymptote on this plane. My x asymptote is free. So I will say 1, 2, 3. I will go where x is free. I will draw a dotted line passing at x is free because this my x asymptote, my x asymptote is free. So this asymptote has to pass where x is free. We call it a vertical asymptote. If you look at the line, it's a vertical line. Another asymptote is the asymptote of y, which is -2. This is a horizontal asymptote. So here at the point of intersection, where these two asymptotes meet, we can ask you to find the coordinates of this point. Suppose we call it M. Suppose we say this point, it's M. What is the coordinates of the point M where the two asymptotes meet, where the vertical asymptote and the horizontal asymptote meets? Those coordinates is going to be 3 and -2. Okay. Okay. We are done with these asymptotes. For sure, you will be able to find the asymptote, the vertical asymptote, and the horizontal asymptote. Now let's talk about the second question. Say, determine the x-intercept of f. So we are looking for the x-intercept of a hyperbola function. The finding of the intercept is very important, grade 11s. You must be able to find the x-intercept, and you must also be able to find the y-intercept. It's very important to be able to find the x-intercept. On 3.2, they are saying, determine the x-intercept. They are looking for the x-intercept of f. You should be able to find the intercept of a function. How do we find the x-intercept of a function? We let y be 0. If you are looking for the x-intercept of a function, you have to let y be 0. Why do we do this? We need to understand what is the x-intercept. In order to understand why, when we are looking for the x-intercept, we let y to be 0, we have to understand what is the x-intercept. The x-intercept, we are referring to the x-cut of the graph. So we are simply saying, where does f of x cut the x-axis? Like, let me do something like this. This point here is the x-intercept, where the graph cuts the x-axis. So we know that exactly at the x-intercept, at the x-cut of the graph, y is equals to 0. So that is why when we are looking for the x-intercept, we let y to be 0. Because when the graph cuts the x-axis, the y value exactly at the point where graph cuts the x-axis, the y is 0. So let's go back to 3.2. Let's find the x-intercept. The first thing that we do, we write the function f of x. We say f of x equals to 1 over x minus 3 minus 2. Then we say let f of x equals to 0. F of x represents y. So we are going to let f of x to be 0. We let our y to be 0. So we say 0, this f of x is 0. So we say 0 equals to 1 over x minus 3 minus 2. From here, we solve for x. We are looking for the x-intercept. We have to solve for x. So we take negative 2 to the left-hand side. So it becomes positive 2. So you're going to have 2 equals to 1 over x minus 3. Okay. Now what do we do? 2 equals to 1 over x minus 3. What do we do now? We have to do what we call cross multiplication. Underneath this 2, it's 1. So we say 2 times x minus 3. We do cross multiply. 2 times x minus 3, which is 2 into x minus 3 equals to, we multiply 1 with 1. 1. Then we continue. We are going to apply distributive law. We're going to say 2 times x is 2x. 2 times negative 3 is negative 6 equals to 1. 2x minus 6 equals to 1. Now everything becomes easy. You say 2x equals to, you take negative 6 to the right side. It becomes 1 plus 6, which is going to be 7. 1 plus 6 is 7. 2x equals to 7. Then you say you divide both sides by 2 in order to solve for x. So x is 7 over 2. This 7 over 2 is 3,5. So the x-intercept of f, it's 3,5. Don't forget, how do we find the x-intercept? We let y to be 0. So I'm going to write my x-intercept here and say x equals to 3,5, which is 7 over 2. Now I'm going to go for the, I found the equation of the asymptotes on 3.1. I found the x-intercept on 3.2. Let me go to 3.3 where they say sketch the graph of f. Sketch the graph of f. On 3.3 they say sketch the graph of f. So in order for us to sketch the graph of a function, we need the x-intercept and also the y-intercept. Okay, on 3.2, we found the x-intercept of this function, hyperbola. So in order for us to sketch this graph, we must also find the y-intercept. So I'm going to look for the y-intercept because I need to sketch the graph. Okay, grade 11s, this is what you need in order to sketch the graph of a hyperbola. For you to sketch a hyperbola, you must have the x-intercept. Okay, and I do have the x-intercept here. It's 3,5. You must also have the y-intercept, which I'm still going to calculate. Another thing, in order for us to sketch the graph, we must know the equation of the asymptotes. Equation of the asymptotes. So this is the three things that you need for you to sketch the graph. You need the x-intercept, you need the y-intercept, you need the equation of the asymptote. So I'm going to go for the number 2 here. I have to find the y-intercept. So how do we find the y-intercept? In order for you to find the y-intercept, you need to let x to be 0. What is actually the y-intercept? The y-intercept is the y-cut of the graph. The y-intercept is the y-cut of the graph. So we are talking about where the graph cuts the y-axis. So if the graph cuts, for example, here, if the graph cuts the y-axis at this point is our y-intercept, the y-cut of the graph. And to find the y-intercept, we must let x to be 0. Always, when you are looking for the y-intercept, you let x to be 0. So let's do that. Let's find the y-intercept. We go to the function f of x. Let's write the function down first. F of x is equals to 1 over x minus 3 minus 2. Then you say f into 0. You put your x to be 0 because you are looking for the y-intercept. 1 over 0 minus 3 minus 2. F of 0 equals to, I advise you to press the calculator now. Just say 1 over 1 divided by minus 3. You subtract minus 2. You use your calculator in this case. I think my answer is going to be 7 over negative 3. Negative 7 over 3. I'm hoping I am correct here because minus 3 minus 2, 6 plus 1. It's 7 divided by minus 3. Yes, it's minus 7 over 3. Let's think about it in a decimal form. What is minus 7 over 3? It's minus 2 comma 3 recurring. Yes, it's minus 2 comma 3. So this is the y-intercept. So I have the x-intercept, I have the y-intercept, and I have the equation of the asymptotes. I should be able to sketch the graph. So let us sketch the graph. What I'm going to do, let me sketch. I need a space. Yes, let me just, where can I have enough space? Yes, I want to put it here. I want to put my graph here. Okay, let me write down all those points that we need in order to sketch the graph. I said to sketch the graph of hyperbola, we need the x-intercept, and the x-intercept, we found it to be 3,5. Okay. Just bear with me for a minute, guys. Let me give. Oh, thanks. Yes, I had to attend someone. So we found the x-intercept. Now let us talk about the y-intercept. What is my y-intercept? It's negative 2,3. And I said we also need the equation of the asymptote. The equation of the asymptote. I will just write A. I am lazy to write other. I mean write in full. I will just say equation of A referring to the equation of the asymptote. So what are the equation of the asymptote? Let us look at the equation of the asymptote. I'm going back to that f of x. The equation of the asymptote was x equals to 3 and y equals to negative 2. X equals to 3 and y equals to negative 2. Okay, x equals to 3, x equals to 3, and y equals to negative 2. These are the asymptote. Now let's sketch the graph. We draw the y-axis. We draw the x-axis, my x-axis, my y-axis. Let us show the asymptote first. The asymptote of x, it's 3. 1, 2, 3. You show the asymptote with a dotted vertical line which cuts the x at 3. The x asymptote is 3. So this dotted line must pass at 3. Another asymptote is the y asymptote of -2. So you draw a dotted vertical line that passes the y-axis at -2. These are the asymptote, guys. And then you have to show the x-intercept. The x-intercept is a point on the x-axis. So the x-intercept is going to be between 3 and 4. This is my x-intercept. It's 3,5. 3,5 is between 3 and 4. And the y-intercept is -2,3. It has to be below -2. Let me put it here. This is the y-intercept. Let me pull my graph down a bit. I'm running. Okay, let me do this because I needed a nice space to show this graph. Okay, the graph will go like this. The graph will go like this. This point cannot go and interact with this one. Remember, the graph cannot cannot pass through the asymptote. So my graph will come here and approach this asymptote. Will get closer to this asymptote and also get closer to the other asymptote. Even this one will approach this asymptote and will also get closer to the other asymptote. Yes. So this is your graph. You name it is the graph of f of x. Hopefully you guys understand what I have done here. This is how you sketch the hyperbola graph. Okay. So let me go back to the questions. Okay, let me, yes. Okay. Okay, now the next question is on 3.4. Let me erase everything here. The only thing I will leave is a graph. I might need this graph when I solve other problems. So I am now on 3.4. Determine the equation of the axis of symmetry of F, which have a positive gradient. Determine the equation of axis of symmetry of F that has a positive gradient. The axis of symmetry of a function is actually the hyperbola function. The hyperbola function has got two axes of symmetry. So they want you to find the axis of symmetry of f. Don't forget that f is a hyperbola function. So you have to find the axis of symmetry of f that have a positive gradient. Okay. Let me say this. The question wants us to find the axis of symmetry which has a positive gradient. But grade 11s know this. The hyperbola function has got two axes of symmetry. The other one has a positive gradient. The other one has a negative gradient. I'm going to show you how to find the axis of symmetry which has a positive gradient in a simpler way. I'm going to say, okay, let us observe our function. Our function is f of x equals to 1 over x minus 3 minus 2. So I'm going to say, okay, let me pick f of x. Let me pick the denominator and pick this minus 2. I will use this part to find the axis of symmetry of a hyperbola function which has a positive gradient. What do you do now? You say y, that f of x is y. Y equals to, you take this x minus 3 and you take this negative 2. Therefore, y equals to x minus 5 is the axis of symmetry which has a positive gradient. This axis of symmetry is actually a straight line. So that is why we have got the equation of a straight line, y equals to x minus 5. So how do we find the axis of symmetry which has a negative gradient? This one here, y equals to x minus 5, is the axis of symmetry which has a positive gradient. How do we find the axis of symmetry with a negative gradient? This is what you do. You still pick y equals to, you still pick x minus 3, your denominator, but this x minus 3, you have to multiply it with negative because you are looking for the axis of symmetry which has a negative gradient. So you take x minus 3, you multiply it with negative. Now you say minus 2. Now y equals to negative times x is negative x. Negative times negative 3 is positive 3 minus 2. Y equals to minus x plus 1. So this is the axis of symmetry which has a negative gradient. So you must be able to find the axis of symmetry of a hyperbola function. The one that has a positive gradient and the one that has a negative gradient. Okay, so that was 3.4. The answer was y equals to x minus 5. This is the axis of symmetry with a positive gradient. Now let's go to 3.5. Okay, now I can erase everything. Actually, I see that I won't need even this graph. Okay, the graph of f is transformed to obtain the graph of h of x equals to 1 over x. Describe the transformation from f to h. Oh, what happened? They are saying there is a transformation which took place. So they are saying they transformed f of x. Remember, f of x is equals to 1 over x minus 3. There is minus 2 here. So they say what happened for us to move from this f of x to h of x. So you can, if you compare h of x and f of x, if you look at these two graphs, you notice that h of x, it has got only x. It does not have minus 3. F of x has got x minus 3. So, but h of x has got only x. So it means that they added 3 here. They added 3 so that minus 3 plus 3 can be 0 so that they can be left only with x. So they added 3 to the x value. So what actually happened? I will say the shift, when you add x, you are actually shifting to the right. Oh, sorry. They shift to the left. When you add to x, you are shifting to the left by 3 units. So they shifted to the left by 3 units. So you can also see now, if you look at h of x, we no longer have minus 2. So it means to this minus 2, they added 2. So that minus 2 plus 2 is 0. So what actually happened? They shifted upward. When you add to y, you are shifting upward by 2 units. So this is what happened to the function f. We shifted to the left by 3 units and we shifted upward by 2 units. Let me explain this actually so that you guys can be able to recall it in your exam. If I give you a function f of x, like this one. I say f of x equals to 1 over x minus 3 minus 2. This function f of x. If I say to you, shift to the left, shift to the left by 3 units. If I say to you, shift to the left by 3, what you do, you just go to the variable x and you add 3. So you simply say f of x equals to 1 over to this x, you add 3. Okay, let us call it, instead of calling it f of x, let's say it's a h of x now. So h of x is equals to 1 over x minus 2. This happens when we have shifted to the left by 3 units. Now, if I say shift upward by 2 units, so I'm simply saying add to the function 2. So you now add 2, you are going up. Minus 2 plus 2 becomes 0. You are left with 1 over x. So h of x is 1 over x. So what actually happened? We shifted to the left by 3 units and we shifted upward by 2 units. 3.6 says write down the domain of h. What is the domain of h? Writing, if you look at h, okay, sorry guys. If you look at h, h of x is equals to 1 over x. So if they ask you to find the domain of h, you do this. You say x can be any real number. X is the element of real number, but x should not be the x asymptote. So what is the x asymptote? The x asymptote of a h of x is 0. Remember, I said finding the x asymptote. You simply take the denominator, you equate it to 0. What is your denominator? Your denominator here, it's x. So if you equate the denominator to 0, you say x equals to 0. This is the x asymptote. And when you write the domain of a hyperbola function, you simply say x can be any real number, but x should not be the x asymptote. The same, let's go to this one of f of x. Let's find the domain of f of x. You say x can be any real number, but x should not be the x asymptote. What is the x asymptote of f? I said when you are looking for the x asymptote, you take the denominator, you equate to 0. The x asymptote is 3. So you say x should not be 3. This is the hyperbola function from Limpopo June exam 2023. Now I'm going to go for a different province. Let us go to KZN grade 11s, and we are still going to look at the function hyperbola. Look at the function hyperbola. So let me start by erasing everything here. We are focusing on hyperbola function, looking at the different question paper. So now we are going to KZN June 2023. This is June 2024, I'm sorry. KZN June 2024. We are looking at the hyperbola function. Okay, this is so interesting. This is interesting. This is a good preparation for June exam, because if you look at this question 4 of KZN, we call it the interpretation of a hyperbola function. So what we will want you, most of the time, we will want you to give us the value of A and also the value of P. They are saying f of x is equals to a over x plus p plus 1. I will say this is the equation of a hyperbola function, but it is not complete. When it is complete, we will be knowing a and we will also be knowing p. So I won't be surprised if they ask us to find a and p. So f of x equals to a over x plus p plus 1. And this hyperbola function has got an axis of symmetry with the equation x equals to 3 minus y. So they are saying this is the axis of symmetry. This is the axis of symmetry. Okay. My advice is this equation of x equals to 3 minus y. It is actually the equation of a straight line. So you must put the straight line in the standard form. You must make y the subject of the formula. So x equals to 3 minus y. What you can do, you can take this y, this minus y, to the left-hand side. You transpose minus y, so it's going to be x plus y equals to 3. Now what you do, you take this x to the right-hand side. You want to make y the subject of the formula. You want y to be left alone. So you take x to this right-hand side. So you are going to have y equals to, this x is going to be negative. So it's negative x plus 3. So this is the axis of symmetry where y is the subject of the formula. So it was very important to put the axis of symmetry in the standard form, y equals to minus x plus 3. Now let's hear the questions. Let's hear what they want. They are saying, write down the range of f. This is a very good question. Hyperbola function, finding its range should be simple. You just say, when you are looking for the range, you just say, y is the element of real numbers. When you are looking for the range of a hyperbola function, you say y is the element of real numbers. But you will also say y should not be the y asymptote. So what is the y asymptote? The y asymptote in this case is 1. I set this number at the end of f of x. This positive 1 is the y asymptote. Is the y asymptote. So finding the range, you say y can be any real number, but y should not be 1. Because that y should not be the y asymptote. The y asymptote, it's 1. We give you 1 mark for finding the range. Y is the element of real number. Y should not be 1. Now they say, determine the equation of the vertical asymptote of f. Okay? The equation of the vertical asymptote of f. Let me remind you, grade 11s, if we go to the Cartesian plane, we have the x-axis and we have the y-axis. And we normally say on the Cartesian plane, we need to show the asymptote. What is the y asymptote? The y asymptote is 1. I set this number at the end. If you go to f of x, the number at the end is the y asymptote. So the y asymptote is 1. You draw a dotted horizontal line on the y asymptote. I'm showing you how to represent the y asymptote. The y asymptote, it's 1. But we don't know the vertical asymptote. I will just draw a vertical line, and I don't know the vertical asymptote, and it's what they are looking for. They are saying on 4.2, they are saying determine the equation of the vertical asymptote of f. So they are looking for the vertical asymptote. We have the horizontal asymptote, which is the y asymptote, which is y equals to 1. So we are looking for the vertical asymptote. How do we find the vertical asymptote? Don't worry, I will show you how to find the vertical asymptote. One thing that I know is that the axis of symmetry, remember we are given the axis of symmetry here, which is x equals to 3 minus y. This axis of symmetry pass at the intersection of the asymptotes, where the vertical asymptote and the horizontal asymptote meet. This is where the axis of symmetry pass. So I have a straight line, which is called the axis of symmetry. This axis of symmetry pass at the intersection of the asymptote. And you still remember this equation of axis of symmetry. They are saying x equals to 3 minus y. Now, at this point of intersection, let me draw a circle on the point I'm talking about. At this point, the coordinates of x is not known, but the y coordinates, it's 1. Remember, we've got this equation of y equals 2. So it means that we can find the x coordinate now, because this axis of symmetry pass at this point where x is not known, but y it's 1. So I will use the axis of symmetry. Why do I use the axis of symmetry? Because it pass at this point. And then I say, oh, x is what I don't know there, equals to 3 minus, I know y, it's 1. Therefore, x equals to 2. So the equation of the vertical asymptote for 4.2, it's x equals to 2. So the key idea when you are solving 4.2 is to know that the line of symmetry always pass at the intersection of the asymptote. That was the key point when solving 4.2. Now we are going to 4.3. We are going to 4.3. Okay, on 4.2, I found x equals to 2. The range here was y is the element of real number, but y should not be 1. Now I am at 4.3. They are saying if f into 0. So you can see that they are simply saying x is 0. You see where there is x, they have placed 0. F, if you look at the function, it's f of x. But here they are saying f of 0. So they are simply saying x is 0. So when x is 0, y is 2. When we give you something like this, f into 0 equals to 2. We are simply saying when you substitute x with 0 on f, you find y being 2. So we can write this as 0, it's my x, 2, it's my y. Okay, so it means 0 and 2 is a point on f. F is passing through the point where x is 0 and y is 2. So now, the question on 4.3 says calculate the value of a. So I'm going to try to find a. What is a? Is this guy here on f of x. Remember, f of x is equals to a over x plus p plus 1. Okay, so what you do, You now say f of x equals to a over x. You ask yourself, what is this p? What is this p? Now watch out, watch out. I want you guys to listen carefully. Whenever you have got positive sign between x and p, just know that p is the x asymptote but with a different sign. So the magnitude of p is the same as the x asymptote, but p will have a different sign. If the x asymptote is free, it means p is negative 3. If the x asymptote is negative 3, it means p is free. So what is going to be p here? P is negative 2. The value of p is negative 2. How do I know? Because I know that the x asymptote is 2. On 4.2, we found the x asymptote being 2. Remember, the vertical asymptote is the x asymptote. The x asymptote is 2. It means that the value of p is going to be negative 2. So we're going to have x plus negative 2 plus 1. So now we can find this a. Remember, we want to calculate this a guy. How are we going to calculate a? We are simply going to substitute the x on the equation and the f of x with a point 0 and 2. So 0 is my x, 2 is my y. Remember, I said 0 and 2 is a point on the graph of f. So we have a right to substitute x and y, this f of x and x, with a point which is on the graph of f. So I will say my f of x is 2. My x is 0. Now I will start solving for a. Take positive 1 to the left-hand side. So we're going to have 2 minus 1, which is 1. 1 equals to a over minus 2. So what do you do now to solve for a? Cross multiply. You say 1 times negative 2, which is negative 2 equals to a. So we found a 4.3. A is negative 2. Now they say calculate x-intercept of f. They want us to find the x-intercept of f. Okay, let's go back now. Let us update our f of x. This f of x now is like this. F of x equals to, remember I found a to be negative 2. Negative 2 over x. We found this p also to be negative 2. They want us to find the x-intercept of f of x. You still remember how do we find the x-intercept? We let y to be 0. So I'm going to put my y, which is this f of x. This f of x is my y. So I will say 0 equals to minus 2 over x minus 2 plus 1. Now I start solving for x. What do? I'm going to take positive 1 to the left-hand side. So I'm going to have 0 minus 1. So I'm going to have, this should not confuse you. I'm going to have minus 1 equals to minus 2 over x minus 2. Then you two cross multiply. Negative 1 times x minus 2 equals to negative 2. Now you have negative 1 times x, negative x, negative 1 times negative 2, positive 2 equals to negative 2. Minus x, take this positive 2 to that side, minus 2, minus 2. Minus x equals to minus 4. Therefore, x equals to 4. This is your x-intercept. This is for 4.4. X equals to 4. Okay. Now they say draw a neat sketch of f. Okay, remember I said to sketch the hyperbola graph, we need the x-intercept. What is the x-intercept? We found it to be 4. And I also said we need the asymptotes. We found the vertical asymptote. Here it was x equals to 2. And the y asymptote, this number positive 1, gives me the y asymptote. It's 1. So I have the x asymptote and the y asymptote. These are my asymptote. Y is 1, x is 2. These are my asymptote. And this x equals to 4 is the x-intercept. And I said to sketch a hyperbola graph, you need the x-intercept, you need the y-intercept, you also need the asymptote. So I have to find the y-intercept. Let me find the y-intercept. F of x equals to, remember this a we know is negative 2. So how do we find the y-intercept? This is what I'm looking for. How do we find the y-intercept? We let x to be 0. So you say f into 0, oh, and we have it actually. We don't even have to calculate it because we are saying f into 0 equals to 2. This f into 0 equals to, we are simply saying when x is 0, y is 2. And that is the x, that is the y-intercept. The y-intercept refers to the y value where x is 2. So they said f into 0 is 2. So this is your y-intercept. So I have the y-intercept actually is 2. Now I can sketch the graph. Y-axis, x-axis, I have to show the asymptote. The x-asymptote is 2. This guy here, x equals to 2. So you show the x-asymptote, which is the vertical asymptote. The y-asymptote is 1. This guy here. So the y-asymptote is a horizontal asymptote. Then you also show the intercept. What is the x-intercept? Okay, the x-intercept, we said it is 4. So the x-asymptote, it's here. What is the y? I'm saying the x-intercept, it's here, it's 4. This is the x-intercept. What is the y-intercept? Is 2. So the y-intercept, it's here. We put a point here. So what you do, from the point 2, you approach the asymptote. You don't touch it. From here, you approach the asymptote. From here, you approach the asymptote. The same, you're going to approach the asymptote this side. So you have sketched the graph of f of x. You must name it f of x. That was 4.5. Now they say write down the value of x whereby f of x is below 0. They say give us the values of x where f of x is below 0. F of x is below 0 if f of x is below the x-axis. Whenever f of x is below the x-axis, it means it's below 0. So my x-axis is here. My y-axis is here. So f of x, this part of f of x, it's below the x-axis. So it means that the values of x where f of x is below the x-axis is when x is less than equals to 4. Actually, it's from this 4 to the left-hand side. It's where the function f of x is below the x-axis. So let me hear the last question, 4.7. They are saying a straight line y equals to negative 2x plus 5. Let me raise these other things. The straight line y equals to negative 2x plus 5 pass through the point of intersection of the asymptote and also intersect f at p, which is 1 and 3, and q. Okay, it intersect f at 2 points, at p and also at q. Write down the coordinates of q. The straight line y equals to negative 2x plus 5 pass through the point of intersection of the asymptote. Let us draw this straight line they are talking about. Y equals to negative, pass through the point of intersection of the asymptote. So this straight line pass here at the intersection of the asymptote. This is where the horizontal asymptote and the vertical asymptote meet. They intersect here. The straight line pass here. Okay. And intersect F. So this line intersect F at 1 and 3. So this line goes like this. Go and touch F at this point, which is 1 and 3. This point here, where it touches F, it's 1 and 3. And it also go again and intersect F again at Q. It intersect at a point Q. Okay, so they say write down the coordinates of Q. Write down the coordinates of Q. Actually, they are saying we can solve this problem without making a lot of calculation. Okay, but let me do this. I know that y is equals to negative 2x plus 5. And the equation of f, if we remember f carefully, it's minus 2 over x minus 2 plus 1. So they are actually saying this y, which is equals to minus 2x plus 5, intersect with f at this point q. So one way of solving this problem, which will be what I'm doing here, I'm taking a longer approach, but I just want to show you this. One way of solving this problem is to see Q as a point of intersection. It's where these two functions meet. So you have a right to say minus 2x plus 5 equals to minus 2 over x minus 2 plus 1. You are looking for the point of intersection. So you equate the two functions. Then you start to solve for x. Okay, this is going to be minus 2x plus 4. What did I do? I'm taking this positive 1 to this side. It becomes negative. So it's 5 minus 1 is 4 equals to minus 2 over x minus 2. Then you drew cross multiply. Minus 2x plus 4 times x minus 2 equals to negative 2. Then it becomes, let me come here, minus 2x squared plus 4x minus 2x plus 4x minus 8 equals to minus 2. After multiplying these two guys, minus 2x plus 4 with x minus 2. Now you have minus 2x squared plus 8x. You take this negative 2 to this side. It's going to be minus 8 plus 2, minus 6 equals to 0. Let's divide throughout by negative 2. You've got x squared minus 4x plus 3. You're dividing everything by negative 2. Then you factorize. X 3 and 1 minus 3 minus 1. So x equals to 3 or x equals to 1. So the two graphs intersect at 2 points. Intersect where x is 1 and where x is equals to 3. So the coordinates of Q, I'm going to take 3 for Q because I can see where x is 1 here. So I'm going to say the coordinates is 3 minus 2x plus 5 and negative 1. Yes, so the coordinates, it is 3 and negative 1. Hopefully it's making sense. That was seeing Q as the intersection. So I'm also looking if there was a better approach because they are saying this is 2 marks. I'm looking for the better approach because they say it's 2 marks. There was supposed to be a better approach that we can use. I think I took a long try by intersecting the two functions. There was supposed to be a better approach. What can I do? Or maybe this y equals to negative 2x plus 5 is the axis of symmetry. Maybe I did not notice that y equals to negative 2x plus 5 is the axis of, let me check. Let me check if it was the axis of symmetry. It can't be. Actually, what am I saying? That cannot be the axis of symmetry. Yeah, this is what I see for now, guys. I just see where Q is the intersection. So the coordinates is 3 and negative 1, but there should be a better approach, believe me. That was question 4. Please subscribe. I will see you next time. I'll see you next time. I think this hyperbola function, it was interesting. Something like this can come in your exam.